All right, here we go. So we want to evaluate each logarithm. And when you look at these things, I know logarithms are terrifying to a lot of students. And really, we want to get comfortable with logarithms, and they are not terrifying. If we want to evaluate a logarithm, we have log base 3 of 81 and log base 5 of square root of 5, log base 7 of 1 over 49, log base 2 of 2. Well, just in saying those words, if we have a little bit more information, we can really change this to something we feel a lot more comfortable with. So let me, whoa, hey, look at that. That's great. Okay, I'm going to put my face right there. All right, let me show you something. I'm going to really bold this. This is one of the most important phrases that you're going to hear all week, all day, all month. Here it is. Write it down. A log is an exponent. A log is an exponent. All right, so you've got that written down. A log is an exponent. We're going to keep referring back to that same phrase right there. A log is an exponent. And so let's look at this first one. And let me read it again. Log base 3, 81. Well, remember, a log is an exponent. And we're trying to evaluate this right here. So I'm going to go ahead and say it equals x. It equals something we're trying to find. So log base 3 of 81 is x. And a log is an exponent. Log base 3. Remember base? Every exponent has a base. A log is an exponent. The base is 3. Is means equals. A log equals x. So that means x is the exponent. A log is an exponent. So log base 3, it is the exponent x. Well, this must equal 81. Log base 3 of 81 is asking what exponent do we have to raise 3 to get 81? And you might just know this answer, but a really helpful thing is to break down 81. 81 can be broken down to 9 times 9. So over here, 81 is 9 times 9. Each of those 9s. So 81 is 3 to the 4th power. And look at that. When the bases are the same, x and 4, when the bases are the same, we can compare those exponents. So log base 3 of 81 is 4 because 3 raised to the 4th power is 81. Let's continue to see this play out. We've got log base 5 of the square root of 5. Well, a log is an exponent, so it is x. The base is 5. It is the exponent x. A log base 5 is an exponent x, and this must equal the square root of 5. Well, we can rewrite square root as an exponent. Square root of 5 is the same thing as 5 to the 1/2 power. Now that we have the bases the same, we can compare the exponents, so that must mean that x is a half. That means that log base 5 of the square root of 5 is a half. We've evaluated. We found the solution. All right, moving down here. Once again, we're going to set it equal to x because we want to know what this equals. Well, this is log base 7. Log is an exponent. I'm going to set that equal to 1 over 49. So I'm going to take my time simplifying this. I know 49 is 7 squared. And I can rewrite this making the bases exactly the same. 1 over 7 squared is the same thing as 7 to the negative second power. Once the bases are the same, notice we can compare those exponents. X equals negative 2. Negative 2. All right. Finally, let's go light blue. Log base 2 of 2. Let's set this equal to x. Well, the base is 2. A log is an exponent, and I'm going to set that equal to what's on the inside. 2 is the same thing as 2 to the first power. And when we have common bases, we can compare the exponents, and so x is 1. Log base 2 of 2 is 1. So this is really helpful. Remember, let's go back to it. A log is an exponent, everybody. A log is an exponent, and we got to keep remembering that. A log has a base, and that base needs an exponent. All right, take it easy.